account name default. If a pod does not explicitly specify a service account, Kubernetes assigns the default one automatically. This behavior happens without any additional configuration. When a pod starts, Kubernetes provides a service account credential to the pod by mounting them as files. They, these credentials include a token, CA certificate, and the namespace information. They are mounted under the path /where run secrets kubernetes.io service account. The token is used to authenticate to the API server. The CA certificate is used to trust the API server TLS connection. Together, they allowed a secure communication over HTTPS. It is important to separate two ideas here. Authentication answers the question who is the pod, and authorization answers the question what the pod is allowed to do. And authorization come through RBAC policy. A service account and its token only stabilize the identity. They do not grant any permission by themselves. Permission are controlled separately using RBAC. In the lab that follows, we will see this in action. We will inspect the token inside a running pod, use it to call API server, observe the permission denial, and then grant access using RBAC. Let's move to the lab. In this lab, we are going to understand how Kubernetes use service account tokens for authentication and how RBAC authorization control what a pod is allowed to do. We will see how a pod communicate with Kubernetes API server using a token and why permissions are denied until we explicitly allow them. First, we create a dedicated namespace for this lab. This helps keep everything isolated and easy to clean up later. So we are creating a namespace lab service account. Now we can set a current context. So we do not need to specify again and again. Now we are going to create a Alpine default pod to see how this default service account assigned to this pod. So every namespace in Kubernetes automatically has a service account named default. You will notice that when we describe the default service token, it has no token. This is normal in modern Kubernetes version, but it will get a token assigned and mounted in the volume, which we will see if we go inside the pod through exec it command, and if we list where run secrets Kubernetes IO service account, we can see the token. This token has three fields. If we do cut-d dot f2, then we will get the token, and if we do the decode base 64-d, then we can get the detail of the token. Now we can install the curl and run the API server commands to see if we have the access. To run the curl query, we need token, cacrt, and API server, which is kubernetes.io, Kubernetes service default, kubernetes.default svc. Now after installing curl, when we run the query for version, we can see that it is able to succeed. However, this default token cannot access pods API query. So you see 403 error if we run for the pods API query. So now let's create a new service account and see how it will work. So to demonstrate best practice, we now create a custom service account named app user. And now we will create a YAML file for a pod where we can assign service account name as app user. Now if we describe the pod, we can see that service account is mounted. Now we can go to the pod and see the token again, and we will run the version command again and see if we can list the pod now. So same steps, we can again do the list, and if we do the decode to the token, then again we can see that okay, the lab service account app user is the name of the token. We are able to do the version, that means token is working. But if we do the API call for pods, then it will fail. So we are again getting forbidden 403. Now we want to solve this problem. So for that, we have a RBAC model in Kubernetes. We can come out from the pod, and we can use cani command. There is a cani command in, we can run as kubectl auth cani, and it is saying no. Now we can create a role app user reader. This will give a verb get list watch resource pods. Now we are binding the role app user reader binding to the role app user reader, and the service account is the app user. Now role is binded. Now our app user has the permission to list the pod. Now let's if we run the cani command, then we can see it, we are getting answer yes. If we go back to the pod and repeat the steps again, now our pod query should be successful. So we need to set our variables again, and then we will run the curl query again. So now we are able to list. So in this way, we can see how a service account and the RBAC role work together.